Hello and welcome to a new video. Today I will show you how a computer is able to solve a three-dimensional complex video game. For setting up the game we are using Unity, and for teaching the robot to play we use reinforcement learning. We want to have this player pressing first the button and then destroying the pyramid to reach the yellow cube. And the result of the training can be seen here. So, first of all, I want to show you how the environment looks like, and then how to solve it. And then I want to show you which possibilities of movement the player will have. So, the environment looks interesting. You have the player, he can move sideward, forward, backward, and there are all these pyramids in white against which he can drive. And there are also the blue walls to constrain the environments. Also, there is this button. Once the player touches the button, a yellow pyramid will be spawned, and this yellow pyramid has the yellow cube target on top of it. If we go to the player view, we can see this again. So we have the navigation left, right, forward and also backward. We have then this button, and if the player hits the button, randomly somewhere in the environment will be a yellow pyramid spawned. Then the aim is to drive to this pyramid. So for this, the yellow blocks have to be ramped, and once the large block falls down, it's the aim of the player to, as fast as possible, reach it and hit it. So now we will start with a fully untrained player who has to get used to the environment, who has to get used to his own abilities of actioner, and who has to learn about the target. These moments I will also use to show you the game perspective and also the player's perspective itself. As you can see, the player has not many skills in the beginning, but it is just the beginning. Now I want to show you the training process up to 50,000 units, and afterward I want to show you what the player has learned. But now a very important question to you. How do you want to call the player? Write it down in the comments and give likes to your favorite. Good! After 50,000 units of training, it looks already much better. The player is quite fast, discovering everything in the map, even presses the button, but still collides very often with the walls and does not find the pyramid yet. That the player likes the walls so much is visible in the player view. But you can also see that he is interested in touching the button and observing the environment. Here, he also saw the yellow pyramid for the first time. But he doesn't care and prefers driving into the wall. To not continue driving against the wall, the player has to continue its own training to learn that this is bad and does not give any reward. So let's see if he's able to improve hitting the button and hitting the pyramid. Even after 150,000 steps, he is still driving against the wall, but also now against the pyramids, even though these are only the white pyramids. Maybe he's colorblind. But I must say, he's not hitting the wall as often as before. And in the player view, you can see that if the button is close enough, the player also touches it. But he does not touch the pyramid. The player rather prefers touching the button or the white pyramids or the wall. During reinforcement learning, it's always impressive to see tactics and strategies and how everything evolves. To study the development a bit more, we continue training for another 600,000 steps, so up to a maximum of 750,000. And then we take a look how the agent performs. Now 750,000 steps of training are over and the player is able to hit the button and yes! Also hits the pyramid, destroys it, and hopefully also finds the target. And it works. And if we now switch back to the player view, we can see that the player is running through the environment and hopefully not hitting the wall. Yes, he's finding the way to the button, touches it, and now searches the pyramid. And there he sees it. And now the big question, left or right, and left. But he finds his way around and hits the pyramid. And now he has to just hunt the big target, not a small one, but the big target. Hooray! He hits the big target and now we want to see if we can get it a little bit better. This looked already very smooth and good, but now we want to see how to find out if this was already the maximum we can get or if there is still room for improvement. The best player which we can reach is the one who reaches the target fast. So we have certain rewards or punishments during the training process. If the player hits the large cube, he gets a positive reward. For every step that the player needs to reach the reward, he gets a punishment, a very small punishment, but large enough to make the player operate fastly. So now we want to track if the player gets already its maximum reward or if there is room for improvement. So let's take a look at the statistics which we get during the training in the so-called tensor board. There we track, among others, also the cumulative reward. So the reward or punishment which the player gets in every of its played episodes. There we can see, for example, that the reward in the beginning is negative, because the player will not reach the target and only gets punishment for running around randomly. After a certain point, the player knows how to find the target and fastly the reward goes up nearly to the maximum level of 2. 2 is the reward when he hits the top of the large pyramid, but since he has to walk there first, he always gets punishment for every step. This punishment is small, but sometimes he reaches faster and sometimes slower the pyramid. And this creates this fluctuation in our data. it's getting quite clear that with the algorithms that we are using, we reach our limits after around 1 million or a bit more than 1 million steps. So once we have trained for more than 1 million steps, we can stop the training, because then we will have more or less the perfect agent for our setup. Now the time came so that we can see the fully trained agent and that we can see which strategies he has learned in the training camp. Before we start, consider to like and subscribe this channel, and write in the comments if you want to see more of these videos, if you want to see more of the coding, or if you want to see how to create the environments. I'm curious about your feedback. And now, after 1.5 million training steps, you can lean back and take a look which strategies the player has learned. Thank you for watching, and if you want to support me on my journey, please consider to like and subscribe. And if you want to support me a bit more, take a look at Patreon. There you will see videos earlier, and I will upload videos which are too detailed for YouTube. So thanks a lot and see you next time.